Now, let's talk about infinite limits. What is the limit as x approaches 0 of the function 1 over x? What's the answer to that? Well, first, what we need to do is check the limit at the left side and the right side. So let's start with the left side. What is 1 divided by negative 0.1? 1 divided by negative 0.1 is negative 10. But now let's plug in a number that's even close to 0 from the left side. So it's going to be negative again. Let's try negative 0.01. 1 divided by negative 0.01 is negative 100. And if we divide it by negative 0.001, that becomes negative 1000. Notice that the number gets larger and larger, but with a negative sign. So therefore, we could say that this approaches negative infinity. Now, what about the right side of the limit? What is the limit as x approaches 0 from the right? 1 over positive 0.1 is 10, 1 over 0.01 is 100, and 1 divided by 0.001 is positive 1000. As you can see, the number gets larger and larger, so this is going to approach positive infinity. Now, generally speaking, whenever you have a small number, basically 0 from the right side, whenever you have a small number in the denominator, it makes the value of the fraction large. So this is equivalent to positive infinity. Now keep in mind, if it's exactly 0, it's undefined. So it really doesn't exist. But if it's close to 0, that means it's going to be very large. So whenever you have 1 and 0 from the left, it's going to be negative infinity. So just some things to keep in mind. So now let's finish this question. Since these two limits do not match, the left side and the right side, therefore, the limit as x approaches 0 from either side does not exist. Now let's try another problem. What is the limit as x approaches 0 from either side of 1 divided by x squared? So let's evaluate it as x approaches 0 from the left side. So if we plug in 0 from the left, we're still going to get a small number, but it's going to be positive. So you can treat it as 0 from the right. And this is going to become positive infinity. So for example, let's say if we plug in negative 0.01. Negative 0.01 squared is actually positive 0.0001. And 1 divided by that number is positive 10,000. You could type it in your calculator just to confirm it. So that's why we got positive infinity. Now what about the limit as x approaches 0 from the right? So if we plug in 0 from the right, once we square it, it's still going to be a positive number. So it's still going to be small. It's going to be very close to 0, but it's going to be positive. And this is going to be positive infinity. Therefore, the limit as x approaches 0 from the right, from either side, rather, is going to be positive infinity. The number is going to get larger and larger and larger. So that's the answer as x approaches 0 from either side. Now let's move on to another example. What is the limit as x approaches 2 from the left of 1 over x minus 2? Go ahead and try that problem. Now let's use direct substitution. Let's plug in a number that's less than 2. Less than 2 would be like 1.9. 1.9 minus 2 is negative 0.1. And this is going to be negative 10. Now if we try 1.99, on the bottom we're going to get negative 0.01, and that's going to be negative 100. So we can see that we're going to get a negative 0, or 0 from the left, on the bottom. So this is going to approach negative infinity. And this is the answer for this one-sided limit. What is the limit as x approaches 3 from the right of 5 divided by x minus 3? Let's go ahead and evaluate this one. So 3 from the right, we can plug in 3.1. 3.1 minus 3 is 0.1. 5 divided by 0.1 is 50. So notice that we have a very large positive value. So therefore, the limit as x approaches 3 from the right of 5 divided by x minus 3, this is going to be positive infinity. Anytime you get a 0 on the bottom, it's either going to be plus or minus infinity. In this case, since we have a 0 from the right, it's positive infinity. Now what about the limit as x approaches negative 4 from the left of 15 divided by x plus 4? Try that. So let's plug in a number that's close to negative 4 from the left. So here's negative 4. To the left of it is negative 5. So we want to plug in a number like negative 4.1. Negative 4.1 plus 4, that's negative 0.1. 150 divided by negative 0.1 is negative 150. So we get a very large negative value. So we could say that this limit approaches negative infinity. What about the limit as x approaches 2 from the right? Let's say this is x minus 2 with a negative 8 on top. What's the answer? So negative 8 divided by 2 from the right minus 2. This is going to give us 0 from the right. So having 0 from the right, that's going to be like negative or positive infinity. So it's like negative 8 times positive infinity, which in the end will be negative infinity. But let's actually plug in a number to confirm it. So 2 to the right, let's plug in a number that's bigger than 2. So 2.1 could be a good example. 2.1 minus 2 is positive 0.1. Negative 8 divided by positive 0.1 is negative 80. So we have a very large negative number, which means the limit approaches negative infinity. Now, what about this one? What is the limit as x approaches 1 from either side of 1 divided by x minus 1? So let's evaluate it from the left side first. So as x approaches 1 from the left, what is it going to be? Well, we can approximate it by plugging a number that's less than 1. Let's try 0.9. 0.9 minus 1, that's negative 0.1. So this is negative 10. So we know that this is going to be equal to a large negative number. So we can say that the limit as x approaches 1 from the left is going to be negative infinity. Now let's check the right side as x approaches 1 from the right. So we can approximate it using 1.1. So this is going to be positive 0.1. 1 divided by positive 0.1 is positive 10. So therefore this limit is going to approach positive infinity. Now these two limits do not match. So this limit does not exist. Here's another one that you can try. The limit as x approaches 2 from the right of x cubed divided by x minus 2 raised to the second power. Try that. So we can plug in 2 on top. On the bottom, we need to plug in 2.1. We have to plug in a number that's close to 2, but to the right of 2. 2.1 minus 2, that's going to be like 0.1. 0.1 squared, that's 0.01. So what we need to take from this is we're going to get a very large positive number. So therefore, this is going to approach positive infinity. Let's say if you plug in 2.01 instead. (2.01) to the third power, that's about 8.12. And if you divide it by 2.01 minus 2 squared, this is going to be a very large positive number. So in the end, we can see that this is going to approach positive infinity. Now what about the limit as x approaches 3 from either side of this function? Well, if we plug in 3, we're going to have a 0 on the bottom. So we know it's either going to be positive infinity or negative infinity. So we just got to check the sign. So let's start with the right side. On the right side, we need to plug in a number that's bigger than 3. 3.1 minus 3 is a positive number. And 0.1 squared is 0.01. 1 divided by 0.01 is 100 times 8. That's going to be positive 800. So on the right side, it approaches positive infinity. On the left side, if we plug in a number that's, let's say, less than 3, like 2.9, 2.9 minus 3 is negative 0.1. But when you square negative 0.1, you're going to get positive 0.01. So you're going to get the same value, positive 800. So therefore, these two limits, they match. So the limit as x approaches 3 from either side approaches positive infinity due to the square. Everything is going to be positive. What is the limit as x approaches negative 3 from the left? Given this expression, x plus 3 divided by x squared plus x minus 6. In this example, the first thing we need to do is factor. What two numbers multiply to negative 6 but add to the middle coefficient of 1? This is going to be positive 3 and negative 2. So x squared plus x minus 6 is equivalent to x plus 3 and x minus 2. Now, if we plug in negative 3 now, negative 3 plus 3 will give us a 0 on the bottom, but because it cancels, we can use direct substitution in this problem. So all we got to do is replace x with negative 3. So it's going to be negative 3 minus 2, which is negative 5, so the answer is 1 divided by negative 5. Here's another one. What is the limit as x approaches 5 from either side of x squared divided by x squared plus 25? Go ahead and work on this problem. Now, if we plug in 5, we won't get a 0 on the bottom. So in this example, we can use direct substitution. 5 squared, or 5 times 5, is 25. 25 plus 25 is 50, and 25 divided by 50 is 1/2. So this is the answer. Now, what is the limit as x approaches 0 from the left of the expression 2 minus 1 divided by x? So go ahead and try that. So let's start with this term. What's the limit as x approaches 0 from the left of positive 1 over x? We know that 0 from the left, this is going to be negative infinity. So if we have negative 1 over x, this will change to positive infinity. So this becomes 2 plus positive infinity, which in the end will be positive infinity. And let's try plugging in a small number. Let's try plugging in negative 0.01. 1 divided by negative 0.01, that's going to be negative 100. So 2 minus negative 100, that's going to be 102. So we have a very large positive number, which tells us that this limit is going to approach positive infinity. Now, what about the limit as x approaches 0 from the right of the natural log function ln x? What is the answer? It helps to know the graph of ln x. ln1 is 0, by the way. It has the vertical asymptote at 0. So it looks like this. So as you approach 0, which is the y-axis from the right, notice that it goes down to negative infinity. And if you have your calculator, you can confirm it. Let's say if you plug in ln 0.1. This is equal to negative 2.3. Now let's plug in ln 0.0001. So it has to be from the right side, so it has to be positive. This is going to equal negative 9.2. So notice that we get a larger negative. Let's plug in a very, very small number, 1 times 10 to negative 50. So that's like 0.00000, almost 50 times, and then a 1. This is negative 115. So slowly it becomes more negative, as we can see. So that's why it approaches negative infinity. Now what about the limit as x approaches 0 from the left of ln x? Notice that there's nothing on the left side. So therefore this limit does not exist. If you were to type in ln negative 0.1 in your calculator, you're going to get a math error. That means that it doesn't exist. You can't have a negative number inside a natural log. So therefore, the limit as x approaches 0 from either side of ln x also does not exist, because the left side does not exist. But the right side, it approaches negative infinity. Now what is the limit as x approaches 0 of tangent x? Let's go over some trigonometric functions. Now for this, we can use direct substitution. Tangent of 0 is 0. Now let's say if we change it. What if x approached pi over 2? And we still have the tangent function. What's the answer now? Tangent pi over 2 is undefined, so we can't just use direct substitution. So therefore, we need to check the left and the right side. So let's start with the right side of tangent. So let's approach pi over 2 from the right. Pi over 2 is basically equivalent to 90 degrees. So if we want to plug in a number that's close to 90 from the right side, we need to try 90.1. Now feel free to put your calculator in degree mode. Tangent 90.1 is about negative 573 if you round it to the nearest whole number. Tan 90.01 is negative 5,730. So therefore, we can see that it's approaching negative infinity. It's becoming more negative as we get closer to 90. And it makes sense because 90.1 is located in quadrant 2, and tangent is negative in quadrant 2. The limit as x approaches pi over 2 from the left. Now let's say if we plug in 89.9. Tangent 89.9 is positive 573. So we can see that this is going to approach positive infinity. So these two limits, they don't match. They're different. So therefore the limit as x approaches pi over 2 of tangent x does not exist. So anytime you see tangent, just keep in mind that you can replace it with sine divided by cosine. And notice that if you plug in pi over 2, sine pi over 2 is equal to 1. And cosine pi over 2 is 0. Anytime you get a 0 on the bottom, it's undefined. So that's a clue that you need to check the left side and the right side of limits as well. So that limit does not exist. Now what about this one? What is the limit as x approaches 0 from the right of cosecant x? Now keep in mind, cosecant is 1 over sine. and sine of 0 is 0. 1 over 0 is undefined. But since we're approaching 0, chances are our answer is going to be positive or negative infinity. So let's find out which one. Now we'll plug in a number that's greater than 0, since it's to the right of 0. Sine of 0.1 is going to be approximately 0.1 if this is in radian mode. Sine of 0.1 is about 0.0998, which let's round that to 0.1. And 1 over 0.1 is 10. Now if we plug in sine of 0.001, this answer is going to be approximately about 100. So therefore, the numbers are getting bigger and bigger as we approach 0. So we can make the conclusion that the limit as x approaches 0 from the right of cosecant is positive infinity. Now what about the limit as x approaches pi over 2 of secant x? Let's try that. So secant is 1 over cosine. And if we plug in pi over 2, cosine pi over 2 is 0. So it's undefined. So as we approach pi over 2, if we analyze the left and the right side of limits, it's either going to be positive infinity or negative infinity. So let's start with the right side. So cosine of 90.1, is that a positive value or a negative value? 90.1 is in quadrant 2, and cosine is negative. So therefore, we can make the conclusion that this is going to be negative infinity. If you plug in 1, make sure your calculator is in radian mode, or rather degree mode. If you plug in 1 divided by cosine 90.1, you're going to get negative 573. Now on the left side of pi over 2, that's 89.9. The angle is in quadrant 1. Cosine is positive in quadrant 1. So we could say this is going to approach positive infinity. So since these do not match, we could say that the limit as x approaches pi over 2 from either side does not exist. Now here's the last question related to this section. What is the limit as x approaches positive 4 from the right of 1 divided by the square root of x minus 2? So if we plug in 4, the square root of 4 is 2. 2 minus 2 is 0. 1 over 0 is undefined. But since it approaches 4 and it doesn't equal 4, it's either going to be positive or negative infinity. So let's substitute x with 4.1. The square root of 4.1 is going to be a number that's just above 2. So let's make a number. Let's say 2.1. Let's say if we don't have access to a calculator. It's probably going to be less than 2.1. 1 divided by 0.1 is 10. So this is a relatively large positive number. The actual value of the square root of 4.1 is 2.025. And this is actually 40. So this is definitely a bad estimate, but this will lead us to the same final answer. And that is, since we're getting a large positive number, we could say that the limit approaches positive infinity. And that is the answer to the question. So a lot of these problems, you can use direct substitution to get the answer. Just make sure you plug in a number that's close to the value that x is approaching. And it's always going to work if you do it that way. Now let's talk about how to find the vertical asymptote of a function. So let's say if we have the function 1 over x plus 2. What is the vertical asymptote? To find it, set the denominator equal to 0. So the vertical asymptote is going to be x is equal to negative 2. So let's try some more examples. What is the vertical asymptote in this case? So if we set x minus 3 equal to 0, the vertical asymptote is x equals 3. Here's another example. Let's say if the function is x minus 5 divided by x minus 5 over x plus 3. And if we have another one, let's say 7x plus 1 over x minus 2, x plus 1. What are the vertical asymptotes? So looking at the factor in the bottom, x plus 1, we just need to change the sign. So the vertical asymptote is going to be x equals negative 1. And for the factor x minus 2, the vertical asymptote is going to be x equals plus 2. Simply reverse the sign. Now for the next one, for the factor x plus 3, it's going to be x is equal to negative 3. X minus 5 will not lead to a vertical asymptote because it can be canceled. So x equals 5 is a whole. Everything else are vertical asymptotes. What about this one? 1 divided by x squared minus 4. What are the vertical asymptotes found in this rational function? So what we need to do is factor using the difference of perfect squares technique. The square root of x squared is x, and the square root of 4 is 2. And so it's going to be x plus 2 and x minus 2. So we can see that the vertical asymptotes are x equals negative 2 and x equals positive 2. So sometimes you need to factor in order to find it. Here's another example in which you need to factor. So how can we factor x squared minus x minus 2? What two numbers multiply to negative 2 but add up to negative 1? This is going to be negative 2 and 1, so to factor it, it's simply x minus 2 and x plus 1. So therefore, the vertical asymptotes are x is equal to positive 2 and negative 1. Now, for the sake of practice, let's try one more example. Try this one. So take a minute, pause the video, and work on it. So we need to factor everything completely. In the numerator, we could take out an x, which will leave behind x minus 2. In a denominator, we can factor using the difference of perfect squares. The square root of x to the 4th is x squared, and the square root of 16 is 4. Now, we can't factor x squared plus 4 without using imaginary numbers. But we can factor x squared minus 4 because we did it in the last example. And we know it's x plus 2 times x minus 2. So this factor leads to a whole. So we have a whole at x equals positive 2. And this one leads to the vertical asymptote, which is x equals negative 2. Now let's talk about the other factor that was in the denominator, and that is x squared plus 4. Notice that there's no vertical asymptotes or wholes associated with this. If we set it equal to 0, we need to subtract both sides by 4. And so x squared is going to equal negative 4. And if we take the square root of both sides, we're not going to get a real number. Keep in mind the square root of negative 1 is I. So this is going to be plus or minus. The square root of 4 is 2 times the square root of negative 1, which is I. So you get positive 2i and negative 2i. These are not real numbers, they're imaginary numbers. So they don't represent any wholes or vertical asymptotes. So that's why we could ignore x squared plus 4.